So it makes sense now that we would go on to 310 and talk about error in calculations such as area and volume. It certainly makes sense that if the measurements that we're using are not exact, have a certain amount of error in them, then when we use that measurement in a calculation, well, the answer to that calculation is also going to be or going to contain some error or be not exact. Now, in most cases, you won't need to worry about this. However, if the question suggests that you need to give the most accurate answer, then that's an indication that you have to consider the error. Now, you might be thinking, then, if the measurement has a certain amount of absolute error, maybe the absolute error of each measurement would come into deciding how to give your answer to something like area. However, it doesn't. So it's just really simple. It says answers to calculations like area and volume, should not contain any more significant figures. So we're now talking about something very different in terms of the significant figures than the piece of data with the least number of significant figures. Now, the piece of data is just the measurement that you will be using. So, nice example here is about the moon. And why I say it's nice is because there is only one measurement used in finding the surface area. So, the moon has a radius 1,740 kilometres to the nearest 10 kilometres. And even that piece of information is making you sort of think, should we be doing something with absolute error? Between what two values does the moon's surface area lay? Well, yes, in order to answer that, between which two values does the surface area lay? This is similar to the questions you did just in 301. The upper value, the lower value of the area. Answer correct to the same number of significant figures as the radius. It's actually telling you there that really your calculations, because the only measurement involved for surface area, so let me write that up for you just in case you've forgotten. The surface area of a sphere is 4 pi r squared. The only measurement we will use is the radius. Now, just back here, it said when you give your answer to a calculation, it shouldn't contain, so my answer for this calculation for the area should not contain any more significant figures than the measurement that we've used, or the measurement with the least number of significant figures. So because there is only one measurement, this question is saying give your answer to the surface area to the same number of significant figures as the radius. So you can see there that the radius has 3 sig figs. 3 significant figures, the 1, 7 and the 4. So when we get our answer, and we're going to give 2 answers, 2 values, the lowest value that the surface area could be and the highest value that the surface area could be. How do we get those? Because we know that the radius is given as 1740. It's to the nearest 10. That gives us absolute error of 5. Why do we need the absolute error? So that I can adjust this radius. That radius could be as small as, take 5 off, 1735 kilometres, and I will use that to calculate the surface, the smallest the surface area could be, or the radius could actually be 1745 kilometres, and I'll use that to calculate the greatest the surface area could be. And I've got this added complication. My answer to the area can only be to 3 sig figs. So let's take the smallest that the area of the moon, surface area of the moon could actually be. So it's 4 times pi times the smallest the radius could be is this 1735, and that has to be squared according to the formula. I'll just pause the video. You can see there that I've got 37,827,602.98 kilometres squared. Now, and remember, this is our smallest possible surface area. Now, according to the rules about error, it's really inappropriate to give the measurement of the surface area of the moon to this precision, to 2 decimal places of a square kilometre. That's being really precise. So rather than that, which we realistically couldn't be that accurate, although our calculator is giving me these numbers, it says that we should only be giving our answer to this area to as many significant figures as the measurement that I've used. The measurement for the radius was only given to 3 sig figs. I should cut this 37,827,602.98 back to 3 sig figs. That means I'm going to cut it here after the 8. Because the next digit is a 2, it'll have no impact on the 8, but all these other decimal places all these other places get filled with zeros, and I don't include decimal places. So it'll be 37,800,000 square kilometres. Now please pause this video and take your calculator, ensure you're getting these numbers, and understand why we would give the answer as I have it there. I'm going to pause the video and calculate now the largest possible surface area for the moon using the greatest value for the radius that it could possibly be. So I use the same formula for pi radius squared, but this time the radius is the 1745. When I did that calculation, I got 38,264,912.68 square kilometres. Now, like I explained before, that's a very precise number of square kilometres. Realistically, we can't calculate the area with that precision, or that precisely, or that exactly, using a value for the radius which contained error, and that radius measurement only had 3 significant figures. So you can see I've adjusted this calculation, or the answer for the area, back to 3 sig figs. Now that means this time I'm cutting off after the 2, and because there's a 6 as the next digit that I cut off, the 2 rounds up to a 3. So I have 38,300,000 square kilometres. So that's the area, that's the answer to the 2 values that the moon's surface area could lie between.